Hello friends and welcome to the data structures. So today we will be covering a concept known as the circular doubly linked list, which is basically a combination of the circular linked list and a doubly linked list. So we'll start by again revising what is a linked list. So a linked list in simple terms is a linear collection of data elements. These data elements are called nodes. Linked list is a data structure which in turn can be used to implement other data structures such as stacks and queues. Regarding the other types of linked list, I have already covered them in my previous video. So there is a link in the description below, as well as there is a floating link on your screen above. You can click any of the two to be redirected to my previous videos. So now let's begin with what is a circular doubly linked list. So as I have stated, it is similar to a doubly linked list since it has two pointers pointing to the forward node in the linked list as well as to the backward node in the linked list. And similarly, the only difference is that pointers of first and last node, which will point to each other, same as a circular linked list. So this is how the basic structure of a circular doubly linked list looks like. Similar to a doubly linked list, each node has two pointers, one pointing to the next node in the linked list and the other pointing to the previous node in the linked list. Regarding the last node, the forward pointer of last node points to the first node in the linked list and the backward pointer of first node points to the last node in the linked list, which is same as a circular linked list, and hence it is a combination of the circular and doubly linked list. So now I'll begin with the operations on the linked list. So the first would be push operation, where we'll be inserting a new node in a circular doubly linked list. So first would be insertion between two nodes. Now for insertion between two nodes, the procedure is exactly as I have stated in my previous video of doubly linked list. For inserting between two nodes, we just need to change the pointers of the new node as well as the two nodes between which we need to insert the new node. Again, I have inserted a link below as well as there is a floating link on your screen above. Click any of the two to be redirected to my previous video where I have explained in detail how to insert a new node between two nodes in a doubly linked list. Now moving forward, insertion at the beginning of a linked list. So this is the linked list we would be using for inserting a new node. We would be inserting a new node Z between the start pointer and the first node in the linked list, that is node A. So now the first step would be to ensure that the backward pointer of node Z points to the last node in the linked list, that is node E. Since now it would be the first node in the linked list, and for a circular doubly linked list, the backward pointer of the first node always points to the last node in the linked list. So hence now we have changed the pointer to ensure the backward pointer of node Z points to the last node in the linked list. Now the next step is to change the backward pointer of node A to point to the new node Z, since now Z would be the first node in the linked list, and hence there is no longer a need for the backward pointer of node A to point to the last node in the linked list. So here it is, we have changed the backward pointer of node A and it now points to the newly created node Z. The next step would be to ensure that the forward pointer of node Z now points to the node A in the linked list, and here it is, we have changed the same. Now this is how the linked list should look like after the new node Z has been inserted into the linked list. Now there are a few important pointers that needs to be changed before the entire procedure for inserting a node at the beginning of a linked list is completed. So the next step would be to ensure that the forward pointer of node E points to the new node Z in the linked list, since now it would be the first node in the linked list. And finally the last step is to make sure that the start pointer now points to the new node Z instead of node A as it was previously pointing. And here it is, we have changed the start pointer and it points to the new node Z in the linked list. And this is how the final linked list should look like after the node Z has been successfully inserted at the beginning of a linked list. Now we will be beginning with inserting a node at the end of a linked list. So again we would be using the same linked list as we have used in a previous example, with the only difference being node Z will now be inserted at the end of a linked list. So let's begin. The first step would be to make sure the forward pointer of node Z points to the first node in the linked list, that is node A. Since now node Z would be the last node in the linked list, hence its forward pointer should point back to the first node in the linked list. And here it is, we have changed the forward pointer of node Z, which now points to the first node A in the linked list. The next step is to make sure that node E now points to the new node Z in the linked list. Hence, we have deleted the forward pointer of node E to point back to the node A in the linked list. And here it is. Now node E points to the new node Z in the linked list. Since now node E will no longer be the last node and it will point to the next node, that is node Z in the linked list. The next step is to make sure that the backward pointer of node Z now points to node E in the linked list. And here it is, we have changed the same. Now the last step would be to make sure that the backward pointer of node A now points to the new node Z in the linked list. Since now node Z will be the last node as I have stated, hence node A should now point to the new node Z instead of node E as it was previously pointing. And so here it is, we have finally changed the backward pointer of node A to point to node Z in the linked list. And this is how the linked list should look like after node Z has been inserted at the end of a linked list. So these were the operations on linked list for inserting a new node. Now I'll begin with the next operation, that is pop operation, that is deleting a node in a circular doubly linked list. Now first would be deletion between two nodes. Again, as I've stated, the procedure for deleting a node which is already present between two nodes in a doubly linked list is exactly same as I've stated in my previous video for doubly linked list. I've inserted a link below as well as there is a floating link on your screen above. You can click any of the two to be redirected to my previous video where I've explained in detail how to delete a node which is present between two nodes in a doubly linked list. Moving forward, we'll start with deletion at the beginning of a linked list. So this is how we had left a linked list in the previous example after inserting the node Z at the beginning of a linked list. Now we'll again delete this node Z from the beginning of the linked list. So the first step is to ensure that node E now points to node A of the linked list, since now node A will be the first node in the linked list and not node Z. So here it is, we have changed the forward pointer of node E to point to node A in the linked list, which will now be the first node of the linked list. The next step is to ensure that the backward pointer of node A now points to the last node of the linked list, that is node E. Since now it would be the first pointer or first node in the linked list, hence it will now point to the last node of the linked list, that is node E. And here it is, we have changed the backward pointer of node A to point to node E in the linked list. This is done by simply copying the backward pointer of node Z into the backward pointer of node A, or we can also copy the forward pointer of node D into the backward pointer of node A. Any of the two could be done to make sure the backward pointer of node A now points to the last node of the linked list, that is node E. Now the next step would be to ensure that the start pointer now points to the node A of the linked list, since now it would be the first node in the linked list and the start pointer always points to the first node of the linked list. So here it is, we have changed the start pointer to ensure that the start pointer now points to the node A of the linked list. Now we simply need to delete node Z and its corresponding pointers. So here it is, we have deleted the same. If you are using a OOP such as Java, it will automatically delete the same. And this is how the final linked list should look like after node Z has been deleted. Node A is the first node in the linked list now, and the backward pointer of node A now points to the last node of the linked list, that is node E, and the forward pointer of node E now points to the first node of the linked list, that is node A. Similarly, the start pointer now points to the node A of the linked list, since now it is the starting node of the linked list. Now we would be beginning with the next step, that is deletion at the end of a linked list. So this is how we had left a linked list after inserting a new node Z at the end of a linked list. So now we would be again deleting this new node Z from the end of a linked list. So let's begin. So as usual, the first step would be to change the backward pointer of node A, which is the starting node, to ensure that it now points to node E in the linked list instead of node Z, since now node E would be the last pointer or last node in the linked list. So here it is, we have changed the backward pointer of node A to point to node E in the linked list. The next step would be to ensure that the forward pointer of node E points back to the first node in the linked list, that is node A. This can be done by simply copying the forward pointer of node Z into the forward pointer of node E, or rather simply copying the backward pointer of node B into the forward pointer of node E. Any of these two could be done to ensure that the forward pointer of node E now points to the first node of the linked list, node A, instead of node Z as it was previously pointing. The last step is to simply delete node Z and its corresponding pointers. And so this is how the final linked list should look like. Node Z has been deleted from the end of the linked list, and this is how the final linked list should look like. Now there are a few important points which I would like to share before ending this video. The first is, do verify the way you are changing the pointers when inserting a new node or deleting a node. The reason is that if you change the pointers in the wrong way, the entire linked list may be lost, and now there is no way to ensure or to bring back the lost linked list. Hence, please be careful when changing the pointers, and also verify that you do not change the pointers in the wrong way, and then you lose the entire linked list. So thank you. Please do like, share and subscribe if you have enjoyed watching the video. These are a few of the other videos from my channel. You can watch these as well and clear your doubts about data structures. For this video, if you do have any doubts, you can post them in the comments below and I would be happy to answer your doubts.